equal to the first term, a sub 1, times 1 minus r to the n over 1 minus r, where n is the number of terms. You can't see it. A sub 1 is the first term, and r is the common ratio. Okay, so a little bit longer of a formula here, but again, you don't have to memorize it. You just have to know how to use it. Things to be thinking of when you're typing this in the calculator. There's more than one term in the more than one term in the numerator. So you're going to need a set of parentheses here. It's not shown in the formula, but I'm going to put it there anyway so that you can think about that when you're typing it in. So that you don't mess things up there. That's pretty much it. Pretty self-explanatory from there. We just got to be able to plug in the pieces. Yes, it is inside parentheses. So you'll have several sets of parentheses here. Yeah, the n is inside the parentheses. It's not outside the parentheses. Good point. Okay, it's just on the r, not on the 1 minus r. Okay, so let's look at that first example. We have the series. Remember, sometimes they show them instead of the commas, if it's a series, they have the pluses and the minuses. So we got 4, 20, 100, 500. What is our common ratio here? What are we multiplying by every time? We're multiplying by 5, so r is 5. We also need to know our first term. That was given to us. That was 4. And they want S sub 14, so n is 14. Those are the three pieces that we need to be able to plug into our formula here. So S sub 14 is equal to, like I said, I'm going to go ahead and throw that extra set of parentheses in there just so I remember to put it into the calculator. So we have 4 times 1 minus 5 to the 14th, parentheses, parentheses, over parentheses 1 minus r, which in this case was 5. And then I'm just going to type it all in the calculator. As long as you put those parentheses there, you can type it all in at one time. As long as you put those extra parentheses in there, you can type this in all at one time, and it will give you the correct answer. So, really big number, but if you think about it, geometric series or sequences, they're getting really big, really fast, especially if you're multiplying by 5 every single time. So even just adding up the first 14 terms gives us 6,103,515,624. So, big old sum right there. Okay, let's do number 2. We've got 81, 27, 9, 3. So what is our first term is 81. What is our common ratio? 1/3. Okay, 1/3, and n is 20 because they want S sub 20. So S sub 20 is equal to the first term, 81, times 1 minus r. Since it's a fraction, you do need an extra set of parentheses around it. So minus 1/3 to the 20th over 1 minus r. If you want to put the parentheses around that one, you can. You really don't have to. That one will be okay. You just need it when you're raising it to that power. Oops. Sorry, I'm trying. All right. So, parentheses, 81, parentheses, 1 minus, put that 1/3 in parentheses. You have to have that or you're not going to get the right answer. So the answer, the sum of the first 20 terms of this sequence is 121.5. Now this one's not as big because our terms are getting smaller. So we're not adding as much to every single term this time. Or each term doesn't add as much as the term before it. Okay, here's another one. We have 3, 6, 12, 24, 6,144. So this one's phrased a little bit differently. They don't tell us how many terms. We're going to have to figure out how many terms that is. But we know most everything we need. We do know that A1 is 3. We know that R is 2. We're multiplying by 2 every time. But this time we don't know what N is. So we got to throw a little intermediate step in here. We have to use our geometric sequence formula to find out if that last term that they give us is 6,144. That is equal to the first term times our common ratio to the N minus 1. So we got to solve this for N. So we start by dividing by 3. And we get 2,048 is equal to 2 to the N minus 1. This is an exponential equation. When we had exponential equations, what was the first thing that we tried to do? Y'all remember to solve them? We wanted them to have the same base if possible. We wanted them to have the same base as possible. So can we write 2,048 so that it's a base of 2? Probably a pretty good shot. It is an even number. So let's see here. 2 to the 10th, 2 to the 11th. 2 to the 11th is 2,048. So that means that our N is 12. So N is 12. So now we can find the sum, which is what they were really wanting us to find. It is the first term times 1 minus the common ratio to the nth. We had to figure that out, the 12 over 1 minus the common ratio. So our sum is 12,285. Okay, number 4 is very similar to this. So let's do it again. Let's write down what we know and then figure out what we need to know. A sub 1 is 4. R is negative 3. Notice those signs are flip-flopping, so the ratio is negative, and we're multiplying by 3. We don't know N. So let's use our formula again. Our last number is equal to the first term times the common ratio to the N minus 1. So divide by 4 to begin with. 729. 729. Let's see here. 3 to the 4th is 81. Is that 3 to the 5th? Nope, 3 to the 6th. Okay, 3 to the 6th. And technically, we could write that as negative 3 to the 6th, since the other side is negative, has a base of negative 3. It's supposed to have the exact same base there. Negative 3 to the 6th gives us the exact same answer, and I'll prove it to you. Okay, if you put parentheses around it like you're supposed to. So 6 is equal to N minus 1, so 7 is our N. So our sum of the first 7 terms is equal to the first term times 1 minus, make sure that negative 3 is in parentheses, to the 7th, over 1 minus the common ratio, negative 3. Okay, so 2,000, 188. Did y'all get positive when you did it? Did y'all get a positive? I think it's supposed to be positive. All right. Any questions so far? Okay, the next few here are in sigma notation. Okay, they're in sigma notation. So same process, not much different here, but it's in sigma notation instead of being listed out with the terms of the series. So let's identify our key features here. They give us the formula. Okay, that's essentially what they've given us. They've given us the formula. So let's look back at our geometric sequence formula over there. It's a sub 1 times the common ratio to the n minus 1. So let's look at this equation. It doesn't look like there's an a sub 1. So if there's nothing there, what's it assumed to be? 1. Okay, so we need to know a sub 1. That's 1. The common ratio is 2. The number of terms, our index starts at 1 and goes to 25. So the number of terms is 25. So S sub 25 is equal to the first term times 1 minus the common ratio to the nth over 1 minus the common ratio. Multiplying by 1 doesn't do anything. So I'm just not going to worry about putting that in the extra parentheses in my calculator. And we get 33,554,431. So again, that one's getting bigger. Do what? We're getting there. We're getting there. This would be bacteria growth. Could be bacteria growth. Population of bacteria doubles every so often. So when you add up all the bacteria in the first 25 hours. Okay. Number 6. Okay, number 6. Let's identify the pieces. A sub 1 is negative 32. It's that part right there in front. R is negative 1/2. And our index goes from 1 to 8. So our number of terms is 8. So S sub 8 is equal to the first term times 1 minus, remember, it's negative and a fraction. You definitely need parentheses around it. Over 1 minus common ratio. Negative 21.25. Questions so far? Okay. The only difference with 7 and 8 here, notice the indices don't start with 1. They start at a different number. So your n is not going to be 20 for number 7. Your n is going to be 15. A sub 1 is negative 4. R is negative 3. N is 15. You subtract the two numbers and add 1. 20 minus 6 is 14 plus 1 is 15. So S sub 15 is equal to the first term times 1 minus the common ratio to the nth over 1 minus the common ratio. Oh, I mean, well, no. Oh, okay. I did make a mistake. A sub 1 is -4, but that's not the first term in the sum that we're finding here. Okay, we're starting with the sixth term. So I made a little mistake right there. We don't want to use -4. That is A sub 1, but we really need A sub 6. We need A sub 6. So we need to plug 6 into our formula there and get the number 972. 972 is really what needs to go there first. My bad. Okay, there we go. 3,486,784,644. Let's not make the same mistake on number 8. A sub 1 is 81, but we don't need A sub 1. We're starting at 2. So we need A sub 2. So that's 81 times 1/2. So that's 40.5. Plug 2 into the equation to get 40.5. The common ratio is 1/2. And the number of terms, 11 minus 2 is 9, plus 1 is 10. So S sub 10 is equal to the first term of the series that we're looking at, 40.5 times 1 minus the common ratio, 1/2 to the 10th over 1 minus 1/2. If you put 1/2 in as 0.5, you can get away with not using parentheses. So as a fraction, this is 82,863 over 1,024, which is approximately 80.9209. So this is kind of interesting. The sum of 10 of these terms is actually less than the very first term of the actual sequence. It wasn't the term we started with, but it is actually less than the very first term of the sequence. Kind of interesting how that happens sometimes with geometric series. But again, it's because that common ratio is 1/2. Okay, really quickly, let's look at what this says about infinite geometric series. So let's find the partial sums for each of the infinite series below. So the first one, we've got 1/2, 1/4, 1/8, 1/16. So let's identify the important things about this. A sub 1 is 1/2. What's our common ratio? What are we multiplying by every time in that first one? 1/2. Okay, so the sum of the first term is the first term. It's a little redundant there. That's 1/2. If we add the first two terms together, 1/2 plus 1/4. We get 3/4. If we add the first three together, so we add 1/8 to that, we get 7/8. If we add the next term, 1 over 16. I could use the formula, guys, but I'm just, since it's having us find all these, it's just easier to keep adding. The next term would be 1/32. And it looks like S6 is cut off there, so we're adding 1/64. So what's happening to these sums? As we're increasing, as we add an additional number each time, we're getting bigger, but it kind of looks like we have a limit to that. What seems to be the limit to this? 1. those fractions are getting closer and closer to 1. 1/2, 3/4, 7/8, 5/16, 31 32nds, 63 64ths. We're getting closer and closer to 1. So a series that approaches a certain sum is called a convergent series. It converges. If you converge on something, then that means that you're kind of closing in on whatever it is. In this case, we're closing in on a number. Let's look at the other one. We're still starting with the same value. We're starting with 1/2, but what's our common ratio for the second one here? What's the common ratio for the second series? 2. Okay, so let's add these up. 1/2 plus 1 is 3/2. If we add 2 to that, we get 7/2. If we add 4 to that, 15/2. If we add 8 to that, that's 31/2. If we add 9, that's 49/2. If we add 10, it's going to be 69/2. So this one is continuing to get bigger and bigger and bigger. Yes, I did it in fraction form because it's easier to add the numbers that way, but it's still getting bigger, right? 7/2 is bigger than 3/2. 31/2 is bigger than 15/2, so forth and so on. So a series that does not have a certain sum, if we kept going, this is going to keep getting bigger. It's a divergent series. Okay, think about the books, divergent. They're straying away from the norm or whatever you want to call it, perfection. They're diverging. You're going away from something if you diverge. Okay, so here is, what do y'all think the if-then statement here is? What's the condition? What's the difference between converging and diverging? What do you think the difference is? So class. Okay, if r is greater than 1, and let's go with the absolute value of r, then the series is divergent. If the absolute value of r is less than 1, then you are convergent. What if you're equal to 1? You're a really boring series. Because if you just multiply by 1, it's just the same number over and over and over and over and over again. So technically, that would also be divergent, because you're just adding the same number over and over again. But it depends on what number you start with. Start with fraction. Anyways. Just if it's greater than 1 or if it's less than 1, don't worry about 1. You're never going to have to deal with r equal to 1. Okay, so if you are convergent, you can find the sum of an infinite series, only if it converges, okay? Only if it converges, because it starts to level off. Like we were seeing with that other one, we can keep going as long as we want to, but we're just going to keep getting closer and closer and closer and closer to 1. Doesn't matter how long we count it. So to find the sum of a convergent infinite geometric series, here is the formula. It's a little bit simpler. It's the first term divided by 1 minus the common ratio. Notice you don't need to know n, because n is infinity. We're talking about an infinite series, so n is infinity. So it only involves the first term and the common ratio. You can if you have a set number of terms, but if it diverges and you want to find an infinite sum, you're going to keep adding a bigger number every time, so it's going to keep getting bigger and bigger. But if it converges, then what you're adding is not making a big difference on the sum. Okay, so we've got to decide, is it convergent or divergent? If it does converge, then we're going to find the sum. So that very first one, 1, 1/4, 1/16, 1/64, is it convergent or divergent? Convergent, because r is 1/4. So I'm just going to put a C right here. So we can find the infinite sum. That shouldn't have an N. That should just be S. Sorry, the formula should just be S. It doesn't need an N. Because N is infinity, so it's just S. So the sum of this infinite series is the first term divided by 1 minus the common ratio. So this is equal to 4/3. Because 1 minus 1/4 is 3/4, 1/3 is 4/3. All right, number 10. What is the common ratio for number 10? 2/3, 8/3, 32nd, 32/3. R is 4. We multiply by 4 every time. The numerators are increasing. The denominator stays the same. The numerators are increasing by a factor of 4, so we're multiplying by 4 every time. Ratio is greater than 1, so that diverges, so we don't have to find the infinite sum. Okay, 5.8, 3.48, 2.088. Looks like it's converging, right, because our terms are getting smaller, but we need to find out what R is. What do we do when it's not so obvious? We've got to divide. You take a term that's further to the right and divide it by its previous term. So R is 0.6. So this converges. So we can find its sum. It's the first term, 5.8 over 1 minus the ratio. You do need parentheses if you're typing into the calculator, not around the numerator. There's just a single number up there. So our sum is 14.5. Okay, number 12. What's our common ratio? It's negative, right, first of all. .75, 3/4. So that's less than 1, so this converges. Sum is the first term divided by 1 minus the common ratio. Make sure you get that negative in there. $73.1429 is the approximate. We could get a fraction. 5/12 over 7. Either one of those. Okay, now, last few here, same principle. These are actually easier because you can see what the formula, what the common ratio is. Notice how this looks a little bit different. Infinity is the top index. So all these are infinite sums. We're going to do 13 and 15 because I think we've got the hang of this. I just want to point out a little detail, that I messed up on the front. So R is 1/4 for this one. So it does converge. So the sum is the first term, which is -2 over 1 minus the common ratio. So -8/3. Number 15, convergent or divergent? Divergent. Okay, be careful, just because it's a fraction doesn't mean that it's less than 1. 5/2 is a fraction, but 5/2 is greater than 1. So that's divergent. So we'll go ahead and do 16. The ratio is -3/4, so it does converge. But the first term that we plug into the equation is not going to be -6. Because where does the index start? It starts at 2. So we've got to start with plugging in 2. Okay, we're going to start with plugging in 2. So -6 times -3/4 is positive 18/4, which is positive 9/2. Right, yeah. Over 1 minus the common ratio. So you do need to put that 9/2 in parentheses. 9/2 in parentheses, divided by 1 plus 3/4. (18/7), approximately 2.571. Okay, I'm not going to do it, but the answer to number 14 is 35. So if you want to do that one real quick and check it, the answer is